Good day everyone. Definite integrals part 6. In this video, you are going to learn two more new properties. Okay. The first one is integral minus a to a f of x dx is equal to. Here you are going to see two different answers on the RHS depending upon whether f of x is an even function or f of x is an odd function. So, integral minus a to a f of x dx will be equal to twice integral 0 to a f of x dx when f of x is an even function. It will be equal to 0 when f of x is an odd function. So, if you want to understand this property, first you should know what is an even function and what is an odd function clearly. So, let me explain that first. Okay. Now, you consider your f of x is equal to x squared, right? I am first taking a simple algebraic expression. Now, you find what is f of minus x. That means in the place of x, you substitute minus x. You will be getting minus x the whole square. That will be equal to x squared. So, f of minus x is equal to f of x. That means f of x is an even function. Okay. So, what is the definition of even function? If f of minus x is equal to f of x is an even function. Now, consider f of x is equal to x power 5. Now, let us find f of minus x. That will be equal to minus x the whole power 5. Now, minus to the power 5 times, that will be minus. So, you will be getting minus x power 5. So, f of minus x is minus of f of x. That means f of x is an odd function. So, now, what is an even function? If f of minus x is equal to f of x, it is an even function. If f of minus x is equal to minus of f of x is an odd function, right? Now, as far as algebraic functions are concerned, if you have even powers, that is 2, 4, 6, 8, etc., your f of x will be an even function. If you have odd powers, 3, 5, 7, etc., then your f of x will be an odd function. This is regarding algebraic functions. If we check trigonometric functions, you all know cos of minus x is equal to cos x, isn't it? Similarly, secant of minus x is equal to secant x. All the other 4 trigonometric functions, if you consider, sine of minus x is minus sine x, tan of minus x is minus tan x, like that. Therefore, the cos x and secant x, they will be even functions, and the other 4, that is sin x, then tan x, cot x, cosecant x, all these are odd functions. Okay. But if you have sin squared x, there this rule applies. The power is an even number. So, the sin squared x will become an even function. Okay. So, these are the main things you should know about odd function and even function. And this property, it has got two different results. So, using that, let us do few example sums. Okay. Let us see the two sums. Integral minus pi by 2 to pi by 2 sine power 7x dx. The next one is minus pi by 2 to pi by 2 sine squared x dx. Both are sine functions, but the power, here it is odd, here the power is even. That is very important. You have to note it down, right? So, here, because it is sine power 7x, this will become an odd function. But sine squared x, because the power is even, this will become an even function. But generally, in any sum, you have to show that it is odd function or even function, then write the property, then write the result. In case it is an MCQ type, in that case, when you see any odd function, if you are sure, you can immediately tick the answer 0. Okay. So now I will tell you the steps what you have to write for this one. This you do yourself. Okay. So now coming to this, I will take I is equal to integral minus pi by 2 to pi by 2 sine power 7x dx. Here the limits are very important. They should be that minus a to a. So both should be pi by 2, pi by 2. In the lower limit you will have a minus sign like that. So minus pi to pi, minus pi by 4 to pi by 4, minus 1 to 1 like that. So now first let us write f of x is equal to sine power 7x. Then you will write f of minus x is equal to sine power 7 of minus x. You know sine of minus x will be minus sine x. Minus sine x whole power 7 will be minus sine power 7x. So f of minus x is minus of f of x. Therefore, f is odd. Like this you have to prove that f is an odd function. Then you write the property. Integral minus a to a f of x dx is equal to, write the second part alone, is equal to 0 if f is odd. Therefore, I is equal to 0. Do you follow how to write the steps? So, first prove that whether it is an odd function or an even function. Then write which part of the property you have to write it, and then write. If it is odd, you write I is equal to 0. In case you get it as even, you will write twice integral 0 to pi by 2, write the integral, then you will go for the normal integration sum. Okay? So, this sum, you try yourself, definitely it will be easy. Now, let us see two more example sums now. Integral minus pi by 4 to pi by 4 x cube sine power 4x dx. Whenever you see the same limits with a minus sign in the lower limit, you should immediately check for this property definitely. Okay. So now, let us write now your f of x is a product of an algebraic function and a trigonometric function. F of x is x cube sine power 4x. Okay. Actually, by practice you will know. Even without doing, you will be able to say. See, because it is power 4, this part will be plus. This part will be negation. So, the product will be negation. So, it is an odd function. Like that, you will learn it. But now, let me show you. Now, f of minus x is equal to minus x the whole cube into sine power 4 of minus x. This will become minus x cube. Here, this will become sine power 4x because the power is even. So now you have got a minus here. So f of minus x is equal to minus of f of x. Therefore, f is odd. Then let us write that property I is equal to integral minus a to a f of x dx. That will be equal to 0 if f is odd. Okay. Therefore, I is equal to 0. That's all. So, when you follow, when it comes as a product of two functions, you have to check that. See here, integral minus 1 to 1 log mod 2 minus x by 2 plus x dx. Here you should remember one logarithmic property which I told you in the previous video, that is log of anything. That will be, if you have a negation, it will become the reciprocal. Remember that. Now here, the limit is minus 1 to 1. So, let me write the f of x as log mod 2 minus x by 2 plus x. F of minus x is equal to log mod 2 minus of minus x by 2 plus minus x. Okay. That will be equal to log 2 plus x by 2 minus x. This is nothing but I can write this as minus of log 2 minus x by 2 plus x, which is minus of f of x. Do you follow? So f of minus x is minus of f of x. So even here f is an odd function, therefore write that property. So this also becomes 0. So this property, I hope it is clear to you. Here remember the limit. A means A. Pi by 4 means pi by 4. 1 means 1. The lower limit will have a negation. If you get any sum like that, definitely try for this property. Most of the times it might click. Otherwise you can think about some other ways out. Okay. So these sums are clear to you, I hope. So I will be going to another new property now. Now the new property you are going to learn is integral 0 to 2a f of x dx is equal to. Even here you are seeing two different answers and there are some conditions. But don't confuse this with the previous property. There both the limits were some a and it is minus a the lower limit, the upper limit is plus a. Here it is 0 to 2a. Okay. So integral 0 to 2a f of x dx is equal to twice integral 0 to a f of x dx when if f of 2a minus x is equal to f of x. It will be equal to 0 if f of 2a minus x is equal to minus of f of x. This property, normally we will be using it in the middle of some big sums, no, we will be using. But I will give you an example sum where we will be using this property alone. Okay. So now I is equal to integral 0 to 2 pi cos power 5x dx. Now if you don't know this property or if you forget this property, normally what will you do? You will be splitting this, right, as cos power 4x into cos x. That cos power 4x you can write cos squared x the whole squared. Cos squared x you can write 1 minus sin squared x. Then you will be substituting, doing everything. But now if you know this property, this sum can be easily solved. Okay. So now here it is 0 to 2 pi. So now compare it with this left hand side of the formula. So here the 2a is equal to 2 pi, that is your a is equal to pi, right? Your f of x is cos power 5x. Now what we have to see? We have to see f of 2a minus x, whether it is equal to f of x or whether it is equal to minus of f of x. Okay. So now let me write f of x is equal to cos power 5x. Okay. Then f of 2a minus x, that is nothing but f of 2 pi minus x, because 2a is equal to 2 pi. That is equal to cos power 5 2 pi minus x. Cos 360 minus theta is equal to cos theta, you know, in the fourth quadrant. So cos 2 pi minus x is equal to cos x. So you will be getting this is cos power 5x. So you are getting f of 2a minus x is equal to f of x. So you come to the first part of this property. Okay. So now you will get I will be equal to twice integral 0 to a, that is 0 to 2a is 2 pi, a is pi. So now you will get pi and then cos power 5x dx. Now actually I am going to use this property once again. Let us see what happens. Now in the place of 2a I have pi now, right? So now 2a is equal to pi. So my a will be equal to pi by 2 now. The same property I am going to use. So I will write my f of x is also same cos power 5x. Now f of 2a minus x, that will be now f of pi minus x, okay? Because now 2a is equal to pi. So that is cos power 5 pi minus x. What is cos 180 minus theta? Minus cos theta. In the second quadrant, cos theta is negative. So, I will be getting minus cos x. See the power? That is also an odd power. So, I will be getting here minus cos power 5x. So, I am actually getting f of 2a minus x is equal to minus of f of x, right? So now I have to use the second part of this property. So now, since integral 0 to 2a f of x dx is equal to 0 if f of 2a minus x is equal to minus of f of x, I get I is equal to 0. So, first time when I use this property, I use the first part of the property. Second time when I use that property, I use the second part of the sum. Okay? But normally, we may not get many sums like this, no? Fully using this property. This property may be used in middle of the sums, like that. Okay? So, is this sum clear to you? Now, I will tell you one more property which is very rare, but still you should know that property. For that, I will be telling that. Okay. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus again integral 0 to a f of 2a minus x dx. This property I already told you. We may not be using it much in the sums. It's a very rarely used property only. But you should know that it is also a property. So now actually we have seen many properties of definite integrals. Just let me give you a quick recap of the important things what we learned so far. That is integral 0 to a f of x dx will be equal to integral 0 to a f of a minus x dx. This is the property which we use in many sums. Okay. Then integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx, where a less than c less than b. This property we use for which sums? When the integrand is a modulus function or a greatest integer function, mainly modulus. Okay. Then integral minus a to a f of x dx is equal to two results, isn't it? Twice integral 0 to a f of x dx if f is an even function. It is equal to 0 when f is an odd function. Then last you learned integral 0 to 2a f of x dx is equal to two results. Twice integral 0 to a f of x dx if f of 2a minus x is equal to f of x, and 0 if f of 2a minus x is equal to minus of f of x. And this is the property you learnt last, which is not that much used. Apart from this, I told you two properties, a very general one. That is integral a to b f of x dx is equal to integral a to b f of t dt, or integral a to b f of y dy. That is change of variable. Variable alone. The limit will be same, the function will be same. Okay. Then the limits interchanging property. That is when your lower limit is a bigger number and the upper limit is a smaller number, we use integral a to b f of x dx is equal to minus integral b to a f of x dx. Okay. So go through all the sums we have done, and you try the sums in your textbook and whatever extra sums you see. Then in the next video, I am actually going to do some important and some standard sums in which we don't just use one property. We will be using 2 or 3 like that properties in one single sum. That we will see in the next video. And if possible, let me give you one identification video. Not for all sums I will be able to say, but wherever I can identify the sums, that also I will give you an idea. So hope up to this you have understood the definite integrals, the normal ones, using substitution and using the properties. Thanks for watching the video. Share it with your friends and classmates. Thank you.